All right, welcome back. We have an exciting session today. So on behalf of the Air Force Association, welcome again to our 2017 Airspace and Cyber Conference. The topic of this session is breaking the logistics barrier. The rules of engagement for this session are as follows. Our speaker will make a short presentation and then take questions from the audience as time permits. Please write your questions on the question cards that will be passed by our volunteers. Every warfighter will tell you logistics is the key to victory. And over 2,000 years ago, Sun Tzu said the line between disorder and order lies in logistics. We are honored to have with us today a world-class logistician and superb Air Force leader. I've had the chance to work with and know General Pawlikowski for years. We served together or we sat next to each other in the Industrial College of the Armed Forces. So one thing I can tell you about Ellen, two things I can tell you. One, she's very smart, and two, she can play basketball. So please join me in welcoming the commander of the Air Force Materiel Command, a longtime friend of AFA, General Ellen Pawlikowski.
How do I get down? All right, if I can have the, play the video, please.
Somewhere in America's vast Midwest, where once stood a cornfield, the world's biggest aluminum plant is now operating to meet the increased need for this most vital of war metals. The Navy awards the workers the traditional E flag for engineering efficiency. Highest possible testimony that industry is doing its job speedily and well. So huge is the plant, motor cars hurry workers and parts from one end to the other. Humming 24 hours a day, the giant mill consumes huge bars, reducing them by chemistry, electricity, and metallurgy into aluminum ingots, which subsequently are rolled into long, thin, tough sheets of silvery metal. A mile of aluminum for the bodies, the wings, the motors of planes, geared to produce 1.5 billion pounds a year for military requirements alone. South America now sends 75% of the bauxite ore from which this 20th century metal is made. When it comes to getting things done quickly, American industry stands supreme. America is winning the battle of production.
A mile of aluminum, that 20th century material. Can you imagine that? A plant that large, processing. That was the beginnings of our Air Force. World War II. The whole country was mobilized to provide not just our aircraft, but everything else that was involved in supporting our operations. Millions of people in support of those operations. And it was right after that that our Air Force was born. You know, it was truly a national mobilization. Everybody from men, women, and in some cases children were there to support the activities. And it took us 2 years to build up the capability to be able to even begin to support our military operations with that tremendous industrial plant. So the war ends. We stand up the Air Force, and everybody comes home. And that production line becomes more interested in making refrigerators and other things for all of the great soldiers, sailors, airmen, Marines, and Coast Guardsmen that had come home from the war and wanted to make a better life for themselves. And we downsized the military, as we always do. But there was a little bit more of a challenge for our Air Force because, frankly, we were in a new war called the Cold War. And we had 2/3 of the triad which we were being asked to support. And we had to be ready at a moment's notice. I know there's a few people out there that got hair that looks like mine that might even remember those Cold War days. So for our Air Force logistics, we weren't resting. we had to figure out how we were going to be able to support this warfighting capability and to be ready. We couldn't take 2 years to build back up. What we saw when we started this is, you see that picture there? Electronics repair. That was at the end of World War II. All Army soldiers doing that. And then on the bottom there, that was the B-24 production line. Hundreds of planes coming off the line on a daily basis around the country in support of the operations. Thousands of workers. And computers, there was no such thing as embedded computer systems at that time. A computer was the white shirt with the tie, short sleeve sometime. I know how geeky you gentlemen think that is, but that was the trend in computers, right? And they were big machines like this room you see here. And there certainly wasn't any of them embedded in any of our aircraft. So it was a whole separate thing. But as I said, as the country demobilized, we still had to continue to produce. And some of the things that we did in order to do this have set the scene for where we are today. Let's go to the next chart. In addition to that, we moved to not just exclusively industry, but recognizing that we needed organic capability to be able, Secretary James actually talked about this a little bit in the congressional luncheon today, we had to have organic capability because we had to be able to be ready to support at a moment's notice. We couldn't count on and relying on the industry to be able to convert the refrigerators factories into aircraft factories. So we built depots. This is a picture of an aircraft depot in the 1950s. And we had to start dealing with new materials. And then we had our boneyard, all those airplanes. This is a picture of Davis-Monthan from 1950. Stacked them up, one on top of each other. But another thing happened. We stopped building airplanes in the hundreds and thousands. We had to continue to concern more about how we were going to keep older airplanes flying and how we were going to preserve them and how we were going to deal with not having the military force that we had. So one of the things we did was that we turned indeed to civilians. And if you look at what that electronics shop would look like today in any of our logistics complexes, you would find that room is filled with civilians. And you would find, if we go to the next chart, that floor, next chart please, that floor looks very different today than it did back then. The picture here are the 135s, and down on the bottom, I think that's the C-130 line. Very, very different environment. There aren't any, and part of what you see there is you see General Levy right there with his team surrounding a bunch of paper. Because one of the things that we did as we recognized how we had to continue to support these airplanes with less people, with less facilities, and with less money. And so we have transformed the way we do logistics support across the entire Air Force from that time frame back in World War II. Today, if you go out on the, in an operation, say Luke Air Force Base, you will find civilians working side by side with our airmen in maintenance. And in our depots, you will find teams of people. And part of what we implemented in this team process is something that we coined the art of the possible, which takes a look at how do we effectively understand how can we best streamline, how can we best make the usage of every single member of that team. And it is a team process. What they're doing in that picture is they're looking at data, at what's going on in the production of those Global Hawk you see in the background. Very different material than that mile of aluminum we saw in there. Requires a more sophisticated and skilled craftsman to be able to do it. Requires parts availability from a very, very complex set of electronics, and it has to deal with aging airplanes where maybe those parts aren't available and there's diminishing manufacturing sources. So instead of a group of a production line like you might have seen in that factory, that B-24 factory, now you'll see teams of folks like that group down there and like that group that's with General Levy in front of that Global Hawk, looking at data, understanding how can we be more efficient? Where are the constraints in the machine, which we call the production line in our depots today? Working together, flagging those parts that need to be done, getting out in front and pursuing things and aggressively working it. The art of the possible with a focus on affordability and efficiency, because every dollar we spend on fixing an airplane that we didn't need to spend because we weren't as efficient or as effective is one less dollar we have to fix the next one. So the depot you see today includes things like software integration laboratories, because no longer are the computers in one place and the aircraft in the other place, or the other weapon systems. It's fully integrated. And we need teams that understand both aspects of it. So if you go to either Ogden or go to Warner Robins, or you go to Tinker, you will find thousands of software engineers writing software code, working side by side along with the aircraft that is going to use that software, or the distributed common ground system, or whatever it is. So it is a different environment. There's no longer the airman basic that's in there, replacing bulbs on a piece of electronics. These are skilled craftsmen. They are professionals that have been doing this for decades, and they are delivering. Record there, you see that celebration of 107 days to complete that. We have, and that is enabling us to continue to provide the tremendous warfighting capability that we have today. Huge changes in our supply chain aspects of our logistics as well. If we go to the next chart. No longer do we rely on Radar O'Reilly to figure out where the supplies are. Huge network, Defense Logistics Agency, working side by side with the supply chain operations wing to get to know where the parts are and to get the parts around the world, wherever that they're needed. Repair networks, a network that identifies and optimizes what gets repaired where so that we can minimize the transportation it takes to get a part repaired and collect those critical skill sets in one location that enable us to keep the systems that we have today. And then we no longer have boneyards. Davis-Monthan is no longer a boneyard. It is the National Air Power Reserve. And if you look at those airplanes, they're not stacked on top of each other. And if you look really closely, I apologize, the picture's a little small, you will see that they are actually sealed to protect them further, and all of the critical parts off of them have been removed and are in storage. And when you hear about diminishing manufacturing sources, and if we have a part that fails, one of the first places we go is we go to Davis-Monthan, and because this is our reservoir, we're able to pick that part, go and find that part, know where it is, and get it out to where it needs to be in a streamlined fashion. So an example of that is that B-52 there, which was part of the boneyard, literally, that as a result of a loss of a B-52 a few years ago, the Air Combat Command at the time decided they needed another B-52. So we took that B-52 out of the air power reservoir and we rebuilt it with new systems in it, and it flew. That picture is from last December, I think, Lee, when it flew its first flight. So we have recognized in terms of the supply chain, first of all, the critical importance of not throwing anything away, because we never know when we're going to use it, and by making sure that we have a supply system that will allow us to be able to track where things are, where we can get economies of scale when we buy things so that we can make sure that we're most cost effective as we can. So that's the environment today. We have a skilled workforce in our air logistics centers that are breaking records every day at delivering air power for a reduced cost and in a short amount of time. Whether it's the C-130s that the Air Force Special Operations Command needs, or the KC-135s. And they're doing, or the F-15s out of Robins, or the F-16s that actually don't go into depot, but are provided with strong depot support as we repair them. They're dealing with the challenges, many challenges though, that are unique to us today that weren't experienced during World War II. Aging aircraft. Most of the B-52s that are out there are twice the age of the young men that are flying them today. Diminishing manufacturing sources. Things that we never anticipated flying are flying now for 50, 60. We're going to keep the B-52 around forever. But on top of that, we have new systems. We have systems that have new materials, F-35. We have challenges in the environment that we never dealt with before. Paint barns, which are huge consumers of energy and environmental issues. And we are exploring and implementing new ways of doing that. And of course, the supply chain, a critical part of it. But it's not enough. If we were to just rest on our laurels and keep what we have today, we will not be able to provide the air power that the Air Force needs and our nation needs in 2030. We won't be able to deal with the continual diminishing manufacturing sources. We're going to run out of stuff in our air power reservoir. We have to be able to deal with limited ability to test airplanes afterwards because of limited airspace in order to be able to do it, and a limited capability to test every aspect of it. We need to be able to train and retain these skill sets, to include those software engineers, to include cyber experts. And so as we look today in Air Force Materiel Command about what we are going to do in the future in order to continue to sustain this, the world's greatest Air Force, we are looking at a couple of things. So if we can go to the next chart and run the video. Hopefully. There it is.
The world's most powerful Air Force. A history of the most brilliant minds. A legacy of the most powerful warbirds. How do we keep our oldest planes in the air while moving forward? The answer is a new technology with an enterprise plan, where the past and the present are building the future with additive manufacturing. There's a challenge on the horizon, and the Air Force is rising to meet it. Additive manufacturing will put a new kind of power in the hands of our warfighters, a new kind of precision, a global network immediately accessible with the information airmen need to put birds back in the sky faster than ever before. It will put the power to make back into the hands of our makers, extending the life of our legacy fleet and blazing new paths for the next generation. With confidence and readiness, additive manufacturing will be a new era of capabilities and agility. It will be the key to uniting the enterprise. Soon, all of our points of light will shine together from many bases across the globe, illuminating the power of our enterprise. Because as a whole, no one comes close. An era of safety, a secure network, an infinite archive, accessible at any moment, from anywhere. We see the destination, we've locked the target, and we're moving towards it the only way we know how. A focused enterprise approach. We are building the infrastructure, we're blazing the trail, and supporting the future of the Air Force through additive manufacturing.
Some of you may recall that 2 years ago I stood up here and told you that additive manufacturing was one of the game-changing technologies. And now today, what I can tell you is that our airplanes have parts in them that are built by additive manufacturing. And we have still much work to do in order to go further on this. But if you have a chance and you go over to the booth that is featuring innovative airmen. You will find a young man from Tinker Air Force Base that his full-time job is implementation of additive manufacturing or 3D printing, as some of you may recall. I can give you examples of the tremendous success we have had with this. A load-bearing handle on the C5, $1,600 to buy the part. It's no longer available. Defense Logistics Agency says they don't know when they'll be able to get it for us because they have to go send it out to somebody to reverse engineer. We sent that part to our innovation center you see there, and in less than 3 weeks, they took that part, they designed it for additive manufacturing and produced it for $300. Now, the value of this in terms of the challenges we talked about for diminishing manufacturing, the challenges we have with having a global responsibility. Think about this. Vision agile manufacturing. We have a global manufacturing network. Think about this in terms of an aircraft like the F-35 that is going to be used by many of our allies, that instead of storing parts, first I have to guess through analysis, not exactly a guess, at what parts we predict are going to fail. And we do pretty good at that, but not always that good at that. And then I have to stockpile those parts. Well, if I had an additive manufacturing capability where I had digital data for the key components in it, and I had additive manufacturing capability for those metals, the structural metals, in key locations, I just make the part. I don't have to worry about supplying it and delivering it. I can make the part right there and reduce not only the cost associated with the supply chain, but improve the precision and capability and reduce the timelines, most importantly, at which I can turn that airplane. We're not there yet, but we have a number of things that are in place. I talked about, you saw the pictures from the Additive Manufacturing Innovation Center. It's not just additive manufacturing that we're pursuing. At each of our air logistics centers, we are creating innovation centers where we're bringing in and inviting industry to work with us to bring in new techniques. We are looking at the application of robotics significantly in order to enable us to get into and to perform functions on 5th-gen aircraft that we cannot easily do by manual labor today. We're looking at new techniques for applying lasers to be able to handle the materials. We are pursuing what is called condition-based maintenance. Right now, if you look at our plan, our depot approach, our PDM, which stands for Plan Depot Maintenance, that's the middle column of what you see there. We plan it, we schedule it, we do it. And conditions-based maintenance is we get out in front of it. We look at the data and we predict where there's going to be a failure, and we replace and we fix it and we eliminate it before it even becomes a failure, before it even becomes an issue. We also are pursuing the better ways to do software support. You know, General Goldfein talks about how our Air Force is, the key in the future is our ability to bring multiple effects from multiple domains, and that information is going to be the coin of the realm, because it is that person who has the information and can act on it that is going to be the victor. We have to be able to then relook at how we talk about sustainment of our weapon systems and how we support our weapon systems to look more in the context of it being a network of apps and apertures, which means that the software can't be done off in a corner without being involved in the actual operation of the weapon system. So a concept called agile software development, which is used in the industry, is one we are aggressively pursuing with both our industry partners, but also internal to our logistics complexes, where we can be able to quickly field and update software in a cyber secure way. Dialogues with General Goldfein and the operational side is the potential that we may actually have software squadrons or software flights as part of our maintenance squadrons within the Air Force because of the critical importance of being able to respond to changes in that. So in addition to these things, if we go to the next chart, and that may be, we are also, next chart please. Okay. The other part of this is if we are going to be an agile, responsive Air Force and provide multiple effects from multiple domains at a speed that overwhelms our adversary, we need logistics command and control that can keep up with that. So another initiative that's been led by General Levy and General Cooper, who are both in the audience, is to put in place a logistics command and a worldwide logistics command and control network that will enable us to have the visibility of where things are and where they need to be in a decentralized way that will give us the agility to be able to be proactive and enable the logistics support to be out in front of where our operators need these things to be. And that requires a networked concept that includes not just our Air Force, but also the industrial base and our alliances and our international partners. This will enable, right now, the way we handle our supply is it's owned by each of the different combatant commanders and their sub commands, and the flexibility is very limited in terms of how we move things around or even having the visibility. So this is as critical a part of ensuring that we have our logistics, that our logistics can support us as the aspects that I talked about in terms of modernizing and advancing the capabilities that our logistics centers and our airmen that are out on the flight line supporting it. Very much you will see that the types of things that need to be done to support our 5th generation aircraft, our KC-46s, which by the way has more wiring in it than I've ever seen in an airplane because I've walked through it. That means that on the flight line, we are going to need airmen that have the depth and understanding associated with maintaining those airplanes. They have to understand the software in there. They have to understand the specifics if we're going to keep them flying. So you're going to see that it's going to be critical to us to have a command and control system that will be able to point to where the right place is for that repair network and where the right part is and where the right expertise is, and be able to effectively move it as quickly as we can. This will have to be something we will do joint, particularly with our compatriots in Transcom that provide the critical transportation capability. But this logistics command and control network will be absolutely essential, capability will be absolutely essential for us to be able to link the different capabilities, the different people, and the different assets so that we can provide the rapid response capability that our combatant commanders need. We need to be able to respond to General O'Shaughnessy, who has to be ready to fight tomorrow, who may very well have to do that from an austere environment where he hasn't had time to set up the infrastructure. We need to be able to continue to support the fight against violent extremism, which will require us to be able to move and be responsive with munitions and being able to load them and being able to provide the ISR capability and the ground capability. And all of that will hinge on our maintainers and our supply professionals to get it there. And that combination will continue to be airmen wearing uniforms like mine, airmen wearing uniforms that are of more the civilian, and also our contractors. It will be an inextricable combination of those three that is going to enable us to provide what will need to be the world's greatest logistics for the world's greatest Air Force. So we need to break a few more barriers. We need to move our capabilities further out of the industrial age and into the information age, and we have to change our culture to think about this. We cannot continue, we have to continue this journey that we've been on for the last 70 years, away from that picture you saw in the beginning of a mile of aluminum rolling out of a huge plant, and think about that airman that's operating the Alice system for the F-35 in the middle of the desert and needs a part and has to be able to understand where it is and, more importantly, know what he needs to do once he gets it. So that's what we see as the future of logistics, embracing the technology. What you'll see within the Air Force Materiel Command is that we have actually, over the last couple of years, shifted investment both in our science and technology as well as in our acquisition programs to focus on the types of things that I've talked to you about here. Because a vision without resources will never become reality. And we intend continue this journey. And as I said, that this journey will be a partnership between us and the industry if we are really going to make the future the reality that we need when it comes to our logistics. So we broke the barriers in the beginning when we shifted from that, with dealing with the limited resources. We broke the barriers 5-6 years ago when we introduced the art of the possible into our sustainment system. And we'll need to break them once again as we look towards a 2030 logistics capability. And I think with that, Larry, I'm ready for any questions anybody might have.
Okay, thank you, General Pawlikowski. We've got some really great questions from the audience. Would you talk about 3D printing? How is it being deployed?
Well, 3D printing right now is predominantly employed in the Air Force by the use of plastics, which I think most people are familiar with 3D printing. That has been what has, hit the rave, if you will. And where that's being done is in places, for example, at Travis Air Force Base, where they used to make their chocks out of metal or wood, and they were constantly breaking and constantly needing to repair them. And so now they 3D print their chocks out of plastic. They're actually quicker, lower cost, and they last longer because of the way they've been able to design them. So if you could probably go to almost any Air Force base today, and somewhere on that Air Force base there is a 3D printer. But what we have been focusing on in the video you saw here and within Air Force Materiel Commands between the Air Force Sustainment Center and the Air Force Lifecycle Management Center is, if you will, how do we mainstream this? And that means we have to transition from plastic parts into metals. Because plastic works really good, but I don't think I want to replace aircraft parts with a piece made out of plastic. So, for example, in the C5, working collaboratively with the program office, we have produced several pieces that were diminishing manufacturing sources, and they have been pathfinders for us to understand what are the right conditions for making metal parts. Within the Air Force Sustainment Center, they're very heavily using 3D printing to do the reverse engineering of parts. When we get a part in that we can't find a manufacturer for, 3D printing allows us to at least get the dimensions and understand how it's made. And in fact, sometimes that enables us to transition right to a part, depending on it. 2 years ago, I showed you, when I was up here, an impeller for a fan on the B-52. That was done at the Sustainment Center, and every day we are applying it in that way. Now, the vision I showed you here about having materials around the world, we're not there yet. We have work to do there. But I see every day more and more applications. It's used for design. It's used to build test structures at the Air Force test centers. I think that we are within 5 years of seeing a significant increase, particularly at our sustainment centers, as we move to more confidence in being able to make metal parts from them. In the industry, companies like SpaceX and Orbital ATK and Pratt & Whitney and GE, you'll notice the commonality, engines, are 3D printing parts and aggressively working it. So it is not a dream. It is a reality that is going to be a game changer, as I said 2 years ago, when we talk about our ability to sustain and operate our weapon systems.
Thank you. This question is a little long, but I think it's a really good one, and it's a very relevant topic. Additive manufacturing, increased autonomy, deep learning are all great new opportunities, but also open new vectors for cyber attacks. Is the Air Force designing cybersecurity into its new systems, and is it examining new strategies for DT&E and OT&E for these systems that will continuously evolve even after deployed?
Yeah. Okay, the short answer to that is yes. And in fact, if you flip back 2 charts, if we could flip back 2 charts, what you will see underneath the agile manufacturing, you see cyber secure parts libraries. Because we recognize that if we're going to build parts based on digital designs, that we have to be able to protect that information. And the machine, if you will, the 3D printer, has to be cyber secure. So last year when I was here, I talked about the Air Force's cyber campaign plan. And the longer answer to this question is the Air Force Cyber Campaign Plan, which is well underway. The Cyber Campaign Plan includes us building in engineering tools to make sure that as we design new systems and we modify existing systems, that we are addressing cybersecurity right from the beginning. Design tools, if you will, that incorporate cyber resiliency. We have stood up cyber mission defense teams around the Air Force to provide that defense of our which are being trained and equipped to be able to provide cyber defense on all of our weapon systems. We are about to stand up on the 1st of October a cyber test group, which will be headquartered at Eglin Air Force Base, that will have the charter as part of the Air Force Test Center to provide for the cyber testing of all of our weapon systems. And within the Sustainment Center, a major focus on things like our SCADA is also part of our cybersecurity. So 3 years ago, I would have told you that we were behind the power curve when it came to cybersecurity within the Air Force. We still have a long way to go, but we actually have a plan, and we are implementing many aspects of that plan. We just need to stay the course and recognize that the days of separate, not worrying about cyber on any weapon system are over. It has to be part of every weapon system, and we have put the right things in place to get us to that point.
Thank you. How do you see the role of the IMSC expanding in the future? Do you see a possibility of IMSC absorbing the AEF Center?
The
AEF Center.
No, I don't. IMSC's focus is to has always been the role of providing that intermediate command support to the MAJCOMs. And they, in the context of expeditionary airmen, they do have the responsibilities to ensure that the functional area managers understand where airmen need to be. They actually manage the deployments for them. But the Air Expeditionary Center actually does the training and prepares the airmen to go. IMSC's role is the support to the major commands to ensure that they have what they need for their installations and for their mission support, more focused on the installations themselves as opposed to the overall training.
Okay, we discuss fifth-generation aircraft often. What thoughts do you have on training/recruiting fifth-generation maintainers?
Well, I think General Cooper and I both know the importance of good maintainers, right? As we both spent some time on some C-17s that relied on good maintainers to keep them flying. And that's not a fifth-gen airplane. I will tell you that this is going to be critically important to our future, is that we have the skill set to be able to maintain these fifth-gen aircraft. And that is going to require us to have an effective blend of blue suit airmen, civilian professionals in our logistics centers, and our contractors. There are certain things that, as we go forward, that are going to have to be done on the flight line. But I think we need to look at what that combination is. I have opportunities. The maintainer on the flight line has to have more, in some ways, a very broad set of skills. And some of the fifth-gen things that will need to be addressed are probably more done, if you will, in the back shop type of environment, and that, or at a depot level. So I think what we're going to have to do in the future is to make sure we understand what's the skill set that's needed, and make sure that those that are truly specialized, that we don't that we put it in the right place as we build the strategy for how we're going to maintain these.
Okay, we've got time for one more. What are your thoughts on long-term PBL contracts for sustainment at the weapon system level?
Well, we've had mixed results from PBL-like contracts. I think PBL contracts can be extremely effective, but they require that you really understand what performance you want and how you're going to measure it, and then we have to all recognize that what we value may change over the life of a weapon system. So I think that my experience has been that a true long-term contract is probably just going to be prone to having to be modded because the environment will change, our priorities will change, and a performance-based contract says, I know what I want, and I'm going to reward you, or I'm going to pay you based on that performance. And if it's a long-term contract, and what I desire changes, and it does, just because the world changes, then I have to end up changing the contract anyway. And I think the other thing that I've learned over the last 2 years in this job is, even if we do performance-based logistics and we do these long-term contracts, the government still has to own the technical baseline. We still have to have the expertise within the government to understand that weapon system and what are the things that need to be done with it.
Thank you so much, and thank you all for being here. I do want to thank General Pawlikowski again. As I mentioned, General Pawlikowski and I were together as lieutenant colonels in ICAF, and I can't think of a better example of success in the Air Force, of a senior leader in the Air Force than Ellen Pawlikowski. And I hope you all, I know you all feel the way I do, that under General Pawlikowski's leadership, AFMC and all logistics for the United States Air Force is in great hands. Thank you very much.
All right. Thank you, Larry.
Thank you all. Full coverage of the conference can be found